And the recording has started. So again, welcome to the class this evening, everybody. We're here tonight to talk continue our talk about Lesson 5, Support Project Team Performance. So as a reminder, Lesson 5, Support Project Team Performance, explores concepts and tasks related to ensuring the team is doing its best work and stays on track to achieving successful project outcomes. This lesson explores both the people and process domains of the exam content outline, or what you sometimes hear called the ECO. Topic B covered comparing methods for improvement and focusing on communication and accountability. In this session, topic C, we're going to be explaining the various methods we can use for performance measurement. So let's get started with understanding more about how to measure project progress to set it up for success. As you may recall, it is during the planning phase that metrics, baselines, and thresholds, including test evaluation procedures, are established. Now it's time to measure the variances of actual performance against those measures and evaluate the project progress. Here you can see a list of what's possible to measure across the project. A very important measurement that the project sponsor will be interested in is, of course, scope. He or she will want to know what percent of work is completed. Quality, too, is extremely important. What constitutes an acceptable output in terms of defects or other considerations related to quality. The project manager should tailor what needs to be measured and only measure what matters. Only measure what matters is a phrase commonly attributed to John Doerr, who is known for championing the use of objectives and key results, or what's sometimes called OKRs, to set goals. In this lesson, we'll look at evaluating project progress by the subtopics listed here and in this order: by scope, schedule, budget, resources, quality, and then by risk. Before we get started with scope, let's touch briefly on reporting. While Agile teams do not create many reports, they can opt for a hybrid reporting method to generate this more formal data output. Even if some teams are empowered to use Agile methods and procedures, certain contexts may make formal reporting a project requirement, such as in a highly regulated industry. For example, regarding financial services, the Federal Reserve System relies on the timely and accurate filing of report data by domestic and foreign financial institutions. The data collected from these regulatory reports facilitates early identification of problems that can threaten the safety and soundness of reporting institutions and ensures timely implementation of legal corrective actions. Cultural context can also require the use of formal reports. In an article by Lawrence Suda, he states that an organization's culture is its personality, comprised of assumptions, beliefs, values, norms, and tangible signs, artifacts such as reporting, or organization members and their behaviors. Likewise, he also notes that performance measures play an enormous role in determining an organization's culture, what gets measured, such as profits, cost savings, behaviors. For example, is individual or team contributions emphasized? Additionally, whether short-term or long-term thinking drives decisioning and hence performance measurement measures. Lastly, another context that can influence reporting requirements is the preference of the stakeholder or stakeholder group and may require a detailed or a formal approach. This slide lists some of the common reports that the project team may publish. So starting with scope, measurement will help the project team to compare the scope criteria with the method or approach for determining the variance between current state and desired state, and by life cycle development approach. In projects that use a predictive life cycle or development approach, the project manager relies on the approved scope statement, the work breakdown structure or WBS, and the WBS dictionary to define the scope or the scope baseline. The method of doing this, or how they go about doing this to measure that variance, Teams measure completion against that scope baseline. In adaptive projects, scope evolves from the initial product roadmap to items in a release backlog, which are further broken down into iteration backlogs. To measure the variance, the teams continuously check user stories and the definition of done, or DoD, against customer feedback and product requirements. And then in hybrid projects, they may use a combination of any of the above. Throughout the life cycle of the project manager and the project team will leverage these methods to monitor or keep tabs on how closely the project is adhering to the scope baseline. So the scope is validated when the customer accepts the deliverables. The term scope validation comes from the predictive process term validate scope, but the meaning is the same in adaptive life cycles as well. The success criteria determined by the customer, which are their needs and wants, and the team or the product requirements must be in place, and the team establishes a definition of ready, a definition of done, iteration reviews wherein the team and customer inspect the product, and the final acceptance criteria. So let's take a moment here and look at these questions and answer them. So in a predictive development approach, which artifact helps determine the acceptance criteria? In a predictive approach. Anybody?
The scope statement?
Correct. Very good. Thank you very much. Excellent. Okay. Now, in an adaptive development approach, which helps determine that the acceptance criteria for user stories has been met? It's on this page too, by the way.
So the definition of done?
Perfect. Excellent. Thank you very much. Good, 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 good. Moving on to schedule performance. As you learned in the planning phase, a schedule is a model for executing the project's activities, including durations, dependencies, and other planning information. There are various methods for tracking performance across projects. Except for the Gantt chart, which is typically used only in predictive settings, earned value, which we're going to cover more when we discuss budget, quality metrics, and variance analysis are methods that can show how the team is performing compared to baseline or an expectation and can be used in any project lifecycle. In agile approaches, schedule progress, or how well the project is progressing in terms of meeting the schedule, is evaluated by comparing the total amount of work delivered and accepted with the estimates of the work to be completed for the current period. This can be done by reviewing the completed work in the regular sprint demos, determining the rate at which deliverables are produced, validated, and accepted in the given time per iteration, and conducting scheduled reviews to record lessons learned, also known as retrospectives, for correcting and improving processes. The project manager may need to act on the schedule due to performance issues. I mean, we've probably all experienced that at some point, right? The schedule gets behind for some reason. So if so, three methods are typically used. These include 1, adjusting the schedule model, 2, using smoothing and leveling techniques, and 3, utilizing schedule compression techniques. Demand and supply of resources may necessitate a need to adjust the schedule model, but remember that the schedule model is typically changed using our formal change control procedures. Smoothing and leveling techniques can help to compress the schedule without over budgeting your resources. With resource smoothing, the project manager optimizes the resources without extending the schedule. Since the schedule cannot be extended, the project's critical path and completion dates need to remain the same. The project manager must be careful and avoid any delays because it might affect the critical path. Time is crucial in resource smoothing, The schedule is fixed, therefore resources must be optimized accordingly. So the key with resource smoothing is really looking at how can we optimize our resources. Resource leveling is a project management technique used to adjust the start and end dates of tasks in order to better manage limited resources. It involves analyzing the resource requirements of each task and then adjusting the schedule accordingly. This allows for improved resource utilization, increased efficiency, and reduced cost. And then lastly, utilizing schedule compression techniques, including fast tracking and crashing, which was discussed back in lesson 3. As you may recall from lesson 3, fast tracking is a schedule compression method in which activities or tasks that are normally done in sequence are performed in parallel, at least for a portion of their duration, whereas crashing seeks to shorten the duration for the least incremental cost. It can include adding people to activities, working overtime, or paying to expedite deliverables. Okay.
Cindy,
Yes.
can you go back to slide 34? There's a definition. If you could click on that, please.
Oh, sure. Oh, I'm sorry, I did forget to do that. Do y'all need a moment to look at that?
Yeah, I usually copy it
Capture
because
it.
we can't open it on the book.
Oh, okay. Yeah, you could do a screen cap of it. Sorry about that. I'll try to remember to click on those tools as we go.
Thank you.
You're welcome. Okay, so 36. So tracking performance and rendering visualizations is a powerful way of demonstrating progress. Reporting and displaying team progress and accomplishments is extremely important to keep the team motivated, but also for communicating to others about the work of the team. Boards are used in most adaptive methods and they vary by the detail included. For example, in a continuous flow approach, throughput, cycle time, and lead time are more often used, whereas in time box methods, velocity would be the measurement used. In the next few slides, we'll be looking at some examples of visualizations that the project manager can leverage to report on schedule progress, including information radiators, burn charts, and task boards, just to name a few. Information radiators. So starting with the information radiators, we're going to watch this video that describes this type of tool and the value they provide to project teams before we look at a few others in more detail. So let me start this one.
90% of all the information transmitted to the brain is visual. Not surprisingly, visuals are processed 6 times faster than text. We are wired to automatically interpret patterns for instant comprehension with almost zero effort. Examples? What do you see right away? A different shape. And with this, a different size. And with this one, a different color. That brings us to an information radiator. An informator is a type of visual control that displays project information in a place where passers see it and get information without having to ask questions. The far left column of this example starts with the project charter. This lists the project's primary objectives, key features, and cautions and risks. It also lists those who have key roles in its completion: the product owner, the architecture owners, and the team lead. Finally, it provides a logic terms which may not be widely known. The next column of this example indicates any impediments that are slowing or preventing progress on the project. This includes both no standing blockers and those that have been mitigated or completed. This column provides a convenient place for the color coding to reside. In this case, for done, blue for started, red for blockers, and yellow for dependencies. The margin of this example shows the product backlog. It also shows the iteration backlog, the specific tasks being worked on by members of current iteration. The far right section of this example shows the iteration burn down. The red team is burning through its customer stories. This can tell the team whether they are on track or behind the committed work. It also shows the release burn up. This monitors progress of release commitment, iteration by iteration, in a projection of when they will meet their release goal. And finally, it shows working agreement. These agreements detail how the team will work together and what they can expect of each other. Of course, this is just an example. Your information radiator should be customized to meet the needs of your team.
So an information radiator is simply a visual display that presents key project information in a highly visible location, ensuring that all the team members and passersby can see the latest updates at a glance. And these displays can be handwritten, drawn, printed, or electronic, and they often include details like the count of automated tests, velocity, incident reports, and continuous integration status. And some of the main benefits of using the information radiators, of course, are transparency. They promote openness within the team and the stakeholders. It also promotes responsibility by encouraging team members to acknowledge and address issues. And it also encourages engagement. So it helps to spark those conversation and ideas, especially when outsiders visit. Okay. Burn charts, such as a burn up or burn down charts, can show project team velocity. So velocity measures the productivity rate at which the deliverables are being produced, validated, and accepted within a predefined interval. The vertical axis notes the number of story points, whereas the horizontal axis would have the time periods. Drawing a diagonal line between the total number of story points and 0 on the vertical axis indicates the planned velocity for the current iteration. Burn charts are great for the team to track progress. Burn downs generally more so at the sprint and the iteration level, and burn ups more at the release level. A burn down chart can show the number of story points remaining or the amount of risk exposure that has been reduced. As work progresses, the number of story points completed each time period are noted and connected to visibly show the progress as noted by the red line. The team creates a trigger point for when credit can be taken for completion of story points and therefore displayed as burn down. The burn down chart also helps to determine whether the current team velocity is on track and the expected completion status. In this example, we can see that the velocity was better than expected through June 11. However, we can see where there was some leveling off in productivity from June 12 to June 15. Perhaps there was a resource issue or other issue that impeded progress. Had this leveling off had not happened, the team might have completed the burn down ahead of schedule. Okay. Where the burn down chart shows the number of story points remaining or the amount of risk exposure that has been reduced, a burn up chart tracks the amount of work done compared to the expected work that should be done. The purple line shows the total number of story points to be completed for the release, but we can see in iteration 5 an additional 20 story points were added. Had the 20 points not been added, we still would have fell slightly short of plan, but the burn-up chart shows why we fell short overall. Both burn-down and burn-up charts are great for the team to track progress. Burn-downs generally more so at the sprint level, and burn-ups again more at the release level. A few reminders to keep in mind. You want to create a baseline for the burn-down only after estimating the full value of the release backlog. And according to lean principles, decide as late as possible on the stories to be included in each iteration and which are therefore included in the release. Okay. A task board is a visual representation of the planned work that allows everyone to see the status of the tasks. A task board can show work that is already ready to be started, as seen under the to-do heading, work in progress, and work that is completed or quote-unquote done. A task board allows anyone to see at a glance the status of a particular task or the number of tasks in each stage of work. Different color sticky notes can represent different types of work, and dots or numbering can be used to show how many days a task has been in its current position. Flow-based projects, such as those that use Kanban boards, can use these charts to limit the amount of work in progress. If a column is approaching the work in progress limit, project team members can swarm around the current work to help those working on tasks that are slowing the flow period. Task boards are a fantastic way of enabling shared understanding and evaluating progress. By making data visible, everyone has access to work in progress. This creates an atmosphere of transparency and information sharing. Moreover, it enables analysis of blockages with items and columns or queues for an extended period. Let's talk a little bit more about velocity, specifically around estimating velocity. As mentioned previously, velocity measures the productivity rate at which the deliverables are being produced, validated, and accepted within a predefined interval. Some key concepts to keep in mind include: 1, it's useful to be able to estimate how much work a team can complete during a time-boxed iteration. 2, although velocity may vary at the beginning of a project, it should be consistent as iterations are completed. 3, velocity is calculated by estimating the number of story points that can be completed during an iteration. 4, as we saw in the previous chart, velocity can be modified as additional iterations refine the number of story points delivered. And then lastly, and perhaps it goes without saying, the goal is to achieve a constant velocity from one iteration to the next. As a special note, velocity is a unique metric to a project. It can't be used to compare one team with another, as teams are different in their ability and skill. The work is different, as are schedules, and so forth. So you're not going to, be able to say, well, this project and that project should have the same velocity. There would be differences that determine what the velocity will be for a specific project. In continuous flow approaches, we find measuring lead time, cycle time, and throughput useful to measuring progress. Continuous flow is a lean method that allows you to move a single product through every step of a process instead of grouping work items into batches. Think of an assembly line when you think of a continuous flow approach. The method is called this because it allows goods to be delivered to the market continuously, providing the opportunity to deliver value more often to customers. The cumulative flow diagram, CFD, is an analytical tool that allows teams to visualize effort and progress. It shows where impediments will occur. Looking at the graph, the line should be smooth and rise gently as the graph tracks the number of work items entering and exiting the queue. Ideally, this rate should be constant. This graph indicates that there is a potential issue with lead time. A bump or a sudden ascent or descent indicates a surge or a lag in something. Let's shift to the next area of performance measurement, budget, and typical budget challenges on projects. We need to track costs and expenditures, of course, but that function may be centralized and included in a functional department's budget and/or the organization. Management of the project budget may be a shared responsibility. In that case, it is still the project team's responsibility to communicate any problems or challenges. And those challenges might include new or changed project requirements, risks or changes to risk probability or impact, or changes to cost estimates resulting from economic factors like inflation, procurement contract modifications, resource costs, and so forth. So let's explore earned value management, or EVM. This is a technique favored by project managers and project teams to measure project progress by comparing actual schedule and cost performance against planned performance as laid out in the schedule and the cost baselines. EVM can be used in any life cycle or development approach, but the next few slides show the application and predictive approaches. We will take a moment to look at the EVM and Agile methods later. The EVM method involves first assessing the value of work by determining what work has been completed and the value it has contributed to the project. These performance reviews are usually included in project status review meetings. Then, during planning, project work is broken down into work packages and activities. Each work package is assigned a budget and a schedule. Because each increment of work is time-phased, a schedule variance results when work is not completed as scheduled. With this information, the project manager can identify appropriate corrective actions. When cost and schedule variance analysis is conducted at the appropriate time intervals and levels, it can be effective in controlling against further cost and schedule problems. So let's look at the variables that go into conducting earned value management. EVM involves determining 3 independent variables to assess and monitor project cost and schedule performance progress. These 3 variables are used to provide measures of whether work is being accomplished as planned and to forecast project cost at completion. The variables that we're going to look at here are planned value, or PV, earned value, EV, and actual cost, AC. Okay. So planned value, or PV, is the authorized budget assigned to scheduled work. And the net of it is planned value is what you're planning to deliver, right? What we plan to deliver $2,000 worth of a product or service, right? This amount is specified in the project's cost baseline. In simpler terms, again, planned value shows the value expected to be earned or what should be done or completed in a given time. For example, you may have a project that takes 1 year to complete and has a budget of $200,000. At the 3-month mark, you expect to have completed 25% of the work. So planned value at the 3-month mark, therefore, is 25% of that expected completion, or EC, value of $200,000, which would be $50,000, right? 1/4 of that $200,000 budget, okay? So that would be our planned value at month 3, okay? Earned value is the measure of work completed or done expressed in terms of the budget authorized for the work. So in other words, EV is a measurement made up of various parts of both cost and time performance in relation to scheduled or planned cost and time performance. Where PV shows the value expected to be completed or earned in a given time, right? We expect it to be done. EV shows the value actually completed or earned on the project. So EV is simply calculated by multiplying the percentage of work completed by the budgeted cost for the activity is laid out in the cost baseline. Okay, so earned value again equals the percent completed, what was actually completed, times the budget. In the prior example, we determined that the planned value at month 3 was $50,000, right? 25% of the $200,000 project. In reality, the project team completed 20% by month 3, or in other words, they delivered $40,000 then of earned value. So they had planned for $50,000 of value to be delivered, but they only really completed $40,000, and that's what they earned. Okay. To determine the EV of the project work to date, you'll have to look back at the cost baseline to determine how costs were assigned originally. If the planned value was determined by the percentage completed to date method, you will apply the same method of assessing the earned value. So in other words, earned value indicates the value of work performed just simply during a particular period. And then actual cost is the realized cost incurred for the work performed on an activity during a specified time period. Actual cost refers to the total amount of costs incurred while performing the work, either during completion of a scheduled activity or during completion of a work breakdown structure or WBS component. AC will then be compared at each time period to the value that was earned by the work during the same time period. So actual cost is, what it actually costed to deliver X amount at a certain point in time. So the most used EVM measures for schedule control are schedule variance, or SV, and schedule performance index, or SPI. Okay, so schedule variance is a measure of schedule performance expressed as the difference between earned value and planned value. So a positive SV is going to indicate that the project is ahead of schedule. Zero SV indicates that the project is on schedule, and negative would indicate that it is behind schedule. Now, I'll say pretty much the same thing here in just a moment about SPI, but for the exam, you do need to be very familiar with these concepts, and these are just kind of unique unique terms that are just they're unique to the project management profession. If you're managing, some of you may talk about this type of stuff with your projects. Many of you may not, but you do need to be very familiar with it on very large projects. This is certainly something you would need to be familiar with. It's common vernacular in project management. So, just kind of get in, read it over and over and over again. I promise you, you'll get it. Hearing me, state this on a few slides is probably not going to be sufficient for you. In the chat, I put a couple of links to some YouTube videos that I came across. I thought that gentleman did a really good job of succinctly, describing this and putting it into context. So I think you'll find them very useful as well. Okay. Schedule performance index, the equation here on the right, is a measure of schedule efficiency. So when you hear index, you want to think efficiency, and it's expressed as the ratio of earned value to planned value. Okay, so SPI is simply equal to your earned value divided by your planned value. An SPI greater than 1 is going to indicate that your project is ahead of schedule. SPI equal to 1.0 indicates that your project is on schedule, and less than 1 is going to indicate that it's behind schedule. So when you're trying to determine a variance in performance, for example, whether we're on schedule or not, we'll be calculating a difference, right? Subtracting one variable from another. And when we're trying to determine efficiency, how well we're doing or how well the team is performing relative to target, we'll be calculating a ratio, okay, for scheduling. Now looking at EVM measures for cost control. So the most used EVM measures for cost control are cost variance, or CV, and cost performance index, CPI. Cost variance is the amount of budget deficit or surplus at a given point in time expressed as the difference between your earned value and your actual cost. So CV is simply equal to EV minus AC. If you have a positive CV, your budget is you're below budget, which is good, right? Positive, below budget. Zero CV indicates that your project is on budget, and a negative CV is going to indicate that your project is over budget, which is no good. Your cost performance index, again, is a measure of efficiency, cost efficiency of your budgeted resources, and it is expressed as a ratio of EV over AC. So a CPI that's greater than 1.0 indicates that your project is under budget. Equal to 1 means that the project is on budget, and if you're falling less than 1, it indicates that your project is over budget. Okay, so as I stated previously, when you're trying to determine a variance in performance, for example, whether we're on schedule or not, we'll be calculating a difference, right? Subtracting one variable from another. And when we're trying to determine efficiency or how well the team is performing relative to our target, we'll be calculating that ratio. Also, you can see similarities in the calculations for schedule and cost variance and schedule and cost performance index. They're exactly the same, except that EVM measures or schedule control evaluates earned value in relation to planned value, whereas the EVM measures for cost control evaluates earned value in relation to actual costs. So when I say that, the net of EV is used in both calculations, right? schedule control and for cost control, you've got to have EV. You got to know what your earned value is. Okay. So project teams use forecasts to consider what might happen in the future so they can consider and discuss whether to adapt plans and project work accordingly, right? Forecasts can be qualitative, such as using expert judgment about what the future will hold. They can also be causal when seeking to understand the impact a specific event or condition will have on future events. Quantitative forecasts, on the other hand, seek to use past information to estimate what will happen in the future. Quantitative forecasts include estimate at completion, or EAC, and estimate to complete, or ETC. The project manager will engage in EAC or ETC analysis to get an idea of whether additional analysis is needed and possibly whether more funds might be required. So estimated completion, or EAC, this earned value management measure forecasts, again, forecasting, right? Forecasts the expected total cost of completing all work. There are many ways to calculate the estimated completion. Assuming past performance is indicative of future performance, which is most likely the case, right? A common measurement is the budget at completion divided by the cost performance index. During execution, you might need to know how much more money you will need to complete a project. Estimate to complete, or ETC, is an earned value management measure that forecasts the expected cost to finish all the remaining project work. This amount again is called the estimate to complete, or ETC. There are many ways to calculate the estimate to complete. But to calculate EAC, we can divide the budget at completion by the cost performance index that we covered in the last slide. By engaging in the EAC ETC analysis, a project manager is essentially considering efficiencies and deciding how they are working. There are many ways to determine if they could be working more efficiently. These are two ways. ETC is usually used first before EAC. These calculations aren't necessarily required on the exam, but you do need to understand what these techniques are and how they work, because there will be questions about them on the exam. Okay. So let's briefly touch on EVM for Agile and hybrid projects. EVM has been adapted for use in Agile and hybrid projects because they've been proven effective as a set of forward-looking metrics for monitoring and controlling complexity and risky projects. Agile EVM methods are often complicated and probably beyond the scope of the exam. However, here's a quick overview of how the process might work in Agile. First, you would establish the performance measurement baseline to create a reference point for the metric. Then you would probably answer questions, well, how many iterations are required? How many story points are there? What is the release budget? And then finally, you would collect the data at the end of each iteration to calculate your planned value, earned value, and your actual cost. Keep in mind that EVM is usually more focused on the schedule aspects and not necessarily the cost aspects, since cost is a fixed factor in releases. The number of iterations or length of time to complete stories is usually the metric used. Okay. And again, just to restate, I did pop some links to some videos in the chat that I think you would find interesting and would probably gain some value out of. Okay. I'm going to stop here because this puts us about halfway through the content, and it seemed to be a good place to stop. Let me stop and see if there are any questions, and then we'll take a brief break.
Hi, did you say you put the links in the chat?
Yes, can you see it?
No, I can't. Can I get them emailed to me? Because I'm not in the organization any longer, so unfortunately
sure.
the chat is not showing up for me.
And that's Anjanette?
Yes.
Let's see, Anjanette, let me write down your, I tell you, Anjanette, can you, how can I get your email? What's the best way for me to get your email address?
I can I think I
You
can
want
send it to you. No, I don't even see your email.
I'm CH4835.
Okay.
CH4835 at att.com. Yeah,
Okay.
just shoot me a note, okay?
Okay.
And
What was the
I'll
email? CH
4835.
4835. Thank you.
Yes, ma'am. You're welcome. You're welcome. Oh, and okay, and I see you Ted as well. I'll shoot it to you as well, okay? All right, very good. Any other questions right now? I know that's a lot of information to digest. All right, well, with that said, then why don't we take about a 5-minute break, and I'll open it back up for some questions again when we get started back again if you think of anything. But we'll come back about 6:56 or 56 minutes after the hour, okay? That depends on your time zone. Okay, so 5 minutes. I'll see you guys shortly. You do it. This is Beverly Crenshaw game. You're tying yourself in a knot game, and I understand it's important, but the world isn't rest. You don't understand. All right, well, let's go ahead and continue on. So let me flip to the next page. All right, now we're shifting on to resources. So let's talk about how performance works in relation to our resources. So leading human resources, or the team, is a combination of leadership, power, skills, and applying tailored tools to performance measurement. Keep in mind that the team can be comprised of internal and contracted members or suppliers of services. Since resource variations frequently lead to cost variances, resource measurements may be a subset of cost measurements. Since some aspects of human resources performance was explored at length back in topic B of this lesson, in this section we'll just focus on procurement and contract management for human resources, as well as management of physical project resources. This is an area where disputes and conflict and change may occur, so we note here that some of this content is also covered in the next topic, manage issues and impediments and manage change. So key concepts the project manager needs to consider when managing and leading resources include checking in with project suppliers and vendors during the contract period to make sure their work is progressing and whether any changes might impact the budget, but also timeline, quality, or risk. Also understanding if any formal progress reports will be required. Typically, this is documented in the statement work or the SOW. In the event formal reports are not required, the project manager should check in with the supplier to ensure work is proceeding as expected, on time, and within the cost parameters. When work is complete, the project manager will need to arrange a formal acceptance of the deliverables from the supplier. And then finally, the SOW typically delineates the instructions to suppliers and vendors on how to submit invoices for payment. However, the project manager needs to notify the appropriate entity when work has been fulfilled, or typically authorize payment for the invoice. As always, the project team members should consult the communications management plan and contract terms and conditions for the vendors and suppliers working provisions. Okay. Controlling resources also pertains to the physical resources required for the project, including equipment, materials, facilities, and infrastructure. This is critical to continually ensure that those physical resources identified as being required are available as planned. This includes just-in-time availability at the right time, in the right place, and the right amount as planned to control costs and risk exposure. It's also important to realize that when these resources are no longer needed and thus released so as not to incur additional expenses. In addition to monitoring availability, it is important to use a process to monitor the usage or consumption of materials, supplies, and equipment. This process must be performed continually throughout the project. I just found it interesting when I was working in a really huge project. We had like 121 million to spend. It was amazing. It's hard to get money appropriated sometimes, and then it gets very difficult to spend it. And ordering the equipment, we're ordering a lot of hardware. It's just the time and effort to go after and find out whether the stuff's been ordered, whether it's been delivered. It's a project management nightmare, but yeah, it's a lot of fun, needless to say. So to manage the physical resources, you need to understand what has been used and what is still needed at any point in time. This includes reviewing the usage and whether it is in alignment as planned. Monitoring the usage of resources is directly tied to the cost for these resources. Monitoring also indicates whether additional resources will be required in addition to those initially identified. This is critical if there is a potential delay in acquiring additional items. It also addresses how to handle releasing or removing excess supplies when no longer required. Part of the monitoring of resources include verifying what has been used so far and what still may be needed. This also includes the expenditures for the various resources and reporting utilization is identified in the project management plan. From a review, the project manager may need to notify stakeholders of any resource issues they can act on. If the review indicates a change to the schedule or cost baseline is required, this change or changes must be approved through the performance integrated change control process. Right? We'll say that a lot. So this slide basically restates what I just said, but calls out that for predictive approaches, the perform integrated change control process is executed for required changes, whereas for adaptive approaches, backlog reprioritization is what happens or must occur. Where there are contractual disputes, the project manager will consult the operational process assets or OPAs and the contractual agreement first. We'll cover the topic of contract changes in more detail in our last topic, topic E. It's I think next week, I think Monday next week, when we talk about topic E, manage project changes. Okay. So let's turn our attention now to the subject of quality. So quality is closely linked to acceptance criteria for deliverables, and it is also relevant to the project approaches and activities used to produce the project's deliverables. While project teams evaluate the quality of a deliverable through inspection and testing, project activities and processes are also assessed through reviews and audits. In both instances, quality activities may focus on detection and prevention of errors and defects. The objective of quality activities is the same whether they're dealing with an upfront, well-defined set of requirements or a set of requirements that are progressively elaborated and incrementally delivered. Let's look at two development approaches here to evaluating and managing quality. First, in the predictive approach, as the project team produces deliverables, the project manager will use the control quality process to review the deliverable and verify that it meets both functional and non-functional requirements. Often they can identify and suggest potential improvements. They also validate whether the deliverables align with compliance requirements. The project manager uses this process to provide feedback on any variances identified, as well as identify potential approaches to cure any defects or other non-compliance issues. Moving on to adaptive approaches, we know that quality management is built in as part of the process. The team, customer, and product owner together define quality goals and metrics. They also use feedback from their iteration reviews to continuously monitor the quality. A variety of methods are used to measure quality, including service level agreements or SLAs, key performance indicators or KPIs, measures that are stipulated in contracts, and the team's own or adopted frameworks such as Lean Six Sigma. Quality reports are generated through quality audits. This time I'll remember to click on the tool there. So a quality audit is a structured, independent process to determine if project activities comply with organizational and project policies, processes, and procedures. An audit can be conducted regularly on a schedule or in an ad hoc fashion with the objective to improve quality performance of a project. An audit would be part of predictive and some hybrid development approaches, likely those with strict quality standards. Topics that could and should be audited include quality management policy, the collection and use of information, analytical methods, cost of quality, and quality process design. Right. Data representation or visualization tools are discussed in our next few slides here. These visual artifacts are important tools for project managers, and you probably have used some of these. So let's look at the tools project managers use to control quality on a project. Data gathering tools include checklists or check sheets, statistical sampling questionnaires and surveys, and we'll use that when we're gathering our data. For data analysis, we're going to be using performance analysis and root cause analysis. And then for representing our data, types of tools we'll be looking at are cause and effect diagrams, scatter diagrams, control charts, histograms, and Pareto charts. These visual artifacts are important tools for project managers, and we'll be looking at those in a bit more detail here in our upcoming slides. Here's what a sample, but before we kind of get to those tools and everything, here's what a sample quality evaluation process could look like in predictive approaches using the control quality process and some of the tools we've just learned about. First, we can use our check sheets to collect our data. Next, we could plot that data on a histogram to understand the significant ones using the Pareto chart or the 80-20 rule. To aid further analysis, we could use our cause and effect analysis on the chosen problems or solutions. And then finally, we would perform a scatter analysis to understand the correlation between those variables. We've all heard the phrase, a picture is worth 1,000 words. Well, data visualization can help the project team to better understand what may be impacting the quality of the project's deliverables. When we can see what's going on through a visual, we can potentially achieve greater transparency on our projects. One data visualization tool, the cause and effect diagram, breaks down the causes of a problem statement, helping to identify the main or root cause of a problem. This diagram is also called a fishbone diagram because of the shape. You may also hear it referred to as Ishikawa after the organizational theorist who invented it, or it might be called YY. So let's explore one or two of the fishbones on this cause and effect diagram. Quality reports indicate that the product quality is not matching the requirements. The project manager or a trained facilitator worked with the team to identify the issues contributing to poor quality. When asking why questions, the project manager or trained facilitator works with the team to identify the drivers, such as equipment. By asking why again, the facilitator learns that equipment may not be being maintained, is old technology, and it may not be just simply operating correctly. So the goal of the cause and effect diagram is to get to the root cause of the observed problem. Okay? So keep asking those why questions so we can get to that root cause. Another data visualization tool is the scatter diagram or the scatter plot. Scatter diagrams use a traditional graph to represent the relationship between any element of a process, environment, or activity on one axis and the quality defect on the other axis. In the example here, we can see the relationship between our process inputs, such as raw materials, labor, energy, etc., and the impact on the quality characteristics of the deliverable. Up to 10 process inputs results in the quality characteristics, or say quality score, above or around 98. But as the inputs, more inputs are contributed, the quality score begins to diminish. In essence, what we're seeing here, more is not always better. Okay. The project team can also use a control chart to determine the predictability, behavior, and the stability of a process over time. It's ideal for repetitive processes with predictable results. So looking at the graph here, we're going to see that center line first, right here, the mean or the center line, right? This would be the mean or the average quality measurement of our process. The specification limit is the area on either side of the center line or mean of data plotted on a control chart that meets the customer's requirements for a product or service. This area may be greater than or less than the area defined by the control limits. The control limit is the area comprised of 3 standard deviations on either side of the center line, which reflects the expected variation in the data. To determine if corrective action might be needed, the project team could follow what is called the rule of 7. This rule states that if 7 consecutive data points fall on one side of the center line in a control chart, the process might be out of control, even if all points are within the control limits. This rule helps us to detect patterns or shifts that could indicate a problem with the process. For example, if you see 7 consecutive points above the mean, it might suggest a systematic issue that needs investigation and corrective action. In this example, we don't see 7 consecutive data points falling on one side of the center line. Okay, but the rule of 7, I do remember that one being on the exam, so good to be familiar with that particular terminology. All right. Another data visualization tool is the histogram. The histogram. Okay. A histogram is a bar or column chart that graphically represents numerical data. For example, the number of defects per deliverable, a ranking of the cause of defects, the number of times each process is non-compliant, or other representations of a project or product defects. A Pareto chart is a type of histogram used to rank causes of problems in a hierarchical format. It references the 80-20 rule to help to determine the most frequent defects, complaints, or other factors that affect quality, contending that a relatively large number of problems or defects, typically 80%, are commonly due to a relatively small number of causes, typically 20%. This tool demonstrates the frequency of occurrences. And although it analyzes data sets related to a specific problem or issue, it does not define the root cause of the problem. For example, in this chart, we find that the largest number of restaurant complaints indicate the complaints are related to the food being overpriced. This does not tell us, however, what the cause or causes of the food being overpriced is. This is where our fishbone analysis, of course, would come into play. Okay. So we've looked at predictive approaches to quality evaluation and management. Now let's take a moment to look at the adaptive approaches. We mentioned before definition of done or DOD when we discussed monitoring scope earlier on slide 32. But DOD, along with acceptance criteria, also helps us manage quality. In any type of project, whether predictive, adaptive, or hybrid, acceptance criteria is used to perform the final validation or acceptance of deliverables. We will cover these concepts again in lesson 6 when we discuss project closure. However, for the purposes of our discussion here, the creation, updating, and validation are in relation specifically to quality management. On this slide, we see generally what the quality process looks like in an adaptive approach. First, the project team verifies deliverables based on quality standards and requirements such as quality metrics and tolerance. Quality metrics describe a project's or product's attribute or attributes and how to measure it or them, whereas tolerance describes the acceptable variation for a quality requirement. In manufacturing, for example, tolerances define the acceptable range of variation in a product's dimension or performance. For instance, if a part is designed to be 10 millimeters in diameter, a tolerance might specify that the diameter can vary between 9.95 millimeters and 10.05 millimeters. This range ensures that the part will still function correctly even with slight variations. So understanding what a quality metric is and how tolerance relates, quality, the tolerance levels, those are important concepts to remember. Next, the verified deliverables are presented to and accepted by the customer, resulting in accepted deliverables. The project team then measures products and outputs against the project's quality standards. Lastly, when quality standards are neither met nor within acceptable ranges, the team implements corrections and controls. In agile approaches, this often happens in what is referred to as iteration H, or the hardening iteration for final quality assurance. Iteration H is a special iteration that occurs at the end of a program increment in the scaled agile framework. It serves several important purposes, two of which are innovation and learning, and it helps to enable the team to focus attention on improving processes and to engage in learning activities to perform at a higher level on future projects. Okay. So moving on to the subject of risk. Risk monitoring and analysis is connected to managing quality. As we have covered adaptive approaches to risk in depth, let's look now at the predictive risk management processes before moving to the very next topic, managing issues and impediments, which is also connected to risk analysis. Okay. So let's see, I'm going to see if we're going to do a little bit of a discussion here. Can you, before we go on, can you identify some typical risk management practices or use cases for each approach, adaptive approach or predictive approach? Has anybody got any ideas on that they'd like to share or put forth? Can you identify some typical risk management practices?
With a
Might we?
predictive approach, you'd
Yeah,
want
go
to
ahead.
list risks that you think will come up or could come up and
Mhm.
create a plan for what to do if for some of the biggest impacts. Something would totally derail your project, or like a vendor might not be able to deliver. You might have a plan to have a backup vendor.
Yeah, exactly. Yeah, so that would be our, again, in predictive, talking about predictive now, comprehensive risk planning, right? Sitting down at the beginning of the project and just simply starting to list out all those the risks, the potential risks that could happen, right? Documenting them, and it's like you said, starting to make a plan for addressing those. Yeah, absolutely. Yep. Another thing we could do probably in predictive is some critical path analysis, right? Um, Kind of help us to identify the sequence of crucial tasks that determine the project durations, right? So we can do that. What about maybe in some adaptive? How can we kind of go about, you know, managing risk, some good risk management processes there? Maybe a continuous, risk assessment, right? When we're in adaptive, it's kind of the same thing like with predictive. We tend to do this up front most of the time, right? Try to get it all kind of understood, even though in predictive we should still be going back and reassessing, right? But with adaptive or you should be continually, going back and doing your risk assessments, right? It's kind of built in. Yeah. So continuing risk assessment. Um, Another place where you might be able to do that is maybe an incremental delivery, of course, again, we're delivering a little at a time, right? Delivering that work in those small manageable increments, it helps the team to be able to identify and address risks early, or identify new risks. So what I found useful when I was looking at this question, because the documentation doesn't necessarily give you the answer to this, was I just went out and queried, what are some typical risk management practices or use cases, for adaptive and predictive approaches. So it's a good way to learn a little bit more and to kind of get those concepts solidified. Okay, cool. So as we noted in the prior slide, predictive risk management processes are more methodical. As the project proceeds, the project manager needs to monitor the risks and their triggers. And when the time arrives and the risk occurs, the actual implementation of the planned risk response is set in motion. Additionally, during this process, the project manager reassesses risk consistently by monitoring the project and the risk register to identify possible new risks that have changed based on additional information that's now available, as well as risks whose time have passed. The project manager also assesses the effectiveness of the chosen risk response. When monitoring risks, there are several questions the project manager needs to consider. In addition to determining if the project assumptions upon which the risks were identified are still valid, the risk itself may have changed or the time during which it might have occurred may have passed, and therefore the risk register will require some changes or modifications. In addition to monitoring the way in which the identified responses to a risk are being handled, any risk management policies and procedures need to be reviewed to make sure that the project is adhering to those previously defined. During various previous topics, we've repeatedly mentioned the need to monitor and update the contingency reserve where appropriate. So as a reminder, contingency reserves are set aside to implement a risk response or to respond to a risk event should they occur. Okay. And finally, do we, think about this one. Oh, shoot. I think I forgot to turn the page. I'm so sorry. Oh, forgot to turn my page. Like over here, these different questions that we were asking. That's what I was referring to. One of the last questions we'll ask ourselves as a project manager is, do we need to do a risk audit, right? Risk audits are a specific type of project audit that may be performed to examine and document the effectiveness of the implemented risk responses. This also reviews the complete risk management process and its effectiveness, as well as how closely the activities follow the initial risk management plan. The risk audit format should be defined before it's conducted, and if it is a common activity, it might be included in the actual risk management plan. At a minimum, the policies and procedures regarding this risk audit should be part of the organizational process assets available to the project. Okay. Right. A reserve analysis is a method used to evaluate the amount of risk on the project and the amount of schedule and budget reserve to determine whether the reserve is sufficient for the remaining risk. Reserve analysis is concentrated on those contingency reserves for the schedule, often referred to as schedule reserves to account for schedule uncertainty. This analysis technique is used to help determine if additional money or time that needs to be set aside in a reserve account to be allocated for identified risks that are accepted. The reserve analysis is used to determine how much, if any, reserve remains, especially after a problem has occurred. Okay. Risks that are raised during the project life cycle are added to the risk register. A rigorous review of project risks ensure that risks are identified and documented. Newly identified and existing risks on the project risk register must be updated based on the current knowledge and situation. Agile teams may use a simplified form of a risk register. Sometimes this is called a risk list or a log. Okay. All right, so here we have another question. When do you think about risks in a project? And when you think about risk in a project, which do you think are the most serious? And how do you know? When you think about your projects or think about a project in general, what do you think are the most serious risks?
Funding getting cut.
Oh yeah, financial risks, absolutely. Right?
Resource constraints,
Yep,
like the personnel. Yeah.
Yeah, exactly. Lack of skilled personnel, inadequate resources. Yeah, unavailability of key resources. Yeah. Those are two good ones.
Maybe things that would prevent the desired outcome of the project. So like, if it
Scope
affect the
creep.
quality, that's one thing, but it's like if it is going to derail your whole project and you won't be able to create the deliverable, that would be a more
True.
impactful risk.
Exactly, right. Yep. Yep. Scope creep, that comes to mind is some scope creep, right? Some different changes or requests for the project that can come in. Yeah. How about two technical risks, right? Issues related to, technology. Um, maybe all of a sudden you've got a new system that's got to be used now, can cause some problems or delays, right? Stakeholder risks too. So how do you know, when you think about these risks, right? How do you know if they're serious? What can you do?
Well, if they impact your timeline
Your team?
or your budget, right?
Exactly. Yeah, exactly. So you can conduct you could do some risk analysis, right? That considers, hey, looking at the impact, right, to the project and the probability of that event happening as well, right? Yeah, so it comes down to doing some level of analysis that you can quantify those risks. Yeah, exactly. Right. Very good. Very good. So most project professionals would agree that compliance and non-compliance are the highest priorities in any risk management project complement. On the slide here, we're considering compliance in terms of the quality of deliverables, but remember, compliance also applies to project processes and standards. A designated stakeholder or group of stakeholders should be accountable for each compliance requirement in the project and authorized to sign off and approve compliance requirements. Many of these final approvals may not be possible until shortly before project completion because they are subject to ongoing testing. These continued review, this continued type of
But
review
if your
provides
if
an
your
early
modem,
warning.
if your gateways
Uh-oh.
are blue, that means they're still on
Uh-oh.
LTE.
There we go. Yeah. The continued review, this continual type of review provides an early warning of potential threats to compliance and determines an appropriate course of action to remediate the issue before it impacts the project timeline, causes cost overruns, or creates large project risks. Okay. So delivering value is the most important part of the project professional's job. Project managers must always be thinking of how the project can deliver value for the business. During execution or the development part of the life cycle especially, project managers have a toolkit full of processes, methods, and leadership skills to expedite and fine-tune their value delivery. How well the project manager executes their approach and uses these tools, methods, and skills can determine the success of their project and their stewardship of it. This concept is delineated in the process domain of the exam content outline, which clearly states execute project with urgency required to deliver business value, but it is also interconnected with the business environment domain. On the PMI talent triangle, this is the intersection of the ways of working and business acumen. So in conclusion, the objective of our topic this evening was to review how to measure project progress and to set it up for success by explaining the various methods for performance measurement. In terms of the exam content outline, we covered the topics listed here. This concludes our topic on evaluate project progress. So I'll stop here and I'll see if you have any additional questions. All right. Well, if there aren't any additional questions, I want to thank you for your time and your attention during the session. Y'all been great. I encourage you to review, since we got 30 minutes left over here, take a moment, re-review the information we covered tonight as soon as possible. So it'll hopefully solidify some of these concepts. particularly the earned value management. I tell you that, like I said, YouTube's, fabulous for being able to get a good handle on many of the concepts that y'all have been studying, but there's just so much good stuff out there. So I think you'll enjoy those videos if you'll take the time to look over those, maybe, with the time that you have left. But again, if you have any questions, I'll stick around for a couple more minutes, but you can always reach out to me. We'll be back together on Monday and Wednesday next week to finish up this particular lesson. So we've got 2 more topics to cover. And then I'll be with y'all on the closing. So y'all are almost to the end here. So I congratulate y'all for hanging in there. It's a bit of a marathon. So with that said, I want to thank y'all for being here tonight, and I hope y'all have a great evening.
Thank
you, Cindy.
You're
Thank you.
welcome.
Thank you.
Thank
You're welcome. Anytime. Take care.
Thank you so much. I just want to make sure that you have me down because I had to call in today versus logging in through the Teams app.
Okay. I tell you what, can you do me a favor and send me a note, and I will make sure we get it taken care of for the attendance, okay?
Yes, ma'am. Thank you so much.
You're welcome. Take care. Have a great evening.
All right.
Thank you.